Now, Anton will be talking about his Linq2d library, and my question to Anton is, how is it used in your projects? No, not as of now, it's just a pure research project, but, well, it looks very promising. So, can you tell us a couple of things about yourself and what you do and how you came to such a research project? Well, I study in the magistrate department of Novosoft University, and I also teach the students, and in free time I work for IngramMicro and a program on C# for myself, a bit on rasdn.org, and since 2000. And this project was a consequence of the discussions, of the heated discussion that we had on this resource. That's cool. Can you talk a bit about this this feud? Well, in 2018 we had a discussion between the participants of the forum about the Linq functionality in C#. The participants had very hot language and two camps. One part said that Linq was a wrong idea, which we took a general purpose language and added some specialized tool in it that has to do with databases, and if you add something, then you need to add something universal. But the other part said, no, this is a universal tool that is useful for pretty much anything. And the skeptics also mentioned the question of how would you apply Linq for working with pictures or arrays. And I actually decided to do it. I had some ideas on my vacation, how I can do it. The first approach was not very successful. I had to delay it. But this year, because of quarantine and coronavirus, I took this project out of my archive in my laptop and refreshed it. And so now I have something to tell you about. Yeah, I think this year quarantine was definitely updating a lot of, was the reason for updating a lot of projects, and they had some opportunity to work on their pet projects. Is it an open source product? So anyone can use it? Yeah, absolutely. I don't plan any. It's free on GitHub. I don't have any monetization ideas, and so I'll be happy if people use it. Okay, so let's not spend more time and really just listen to how you did it. Yeah, let's do it.
Итак, как я уже говорил, проект получился в результате спора.
So, as I said, this was a consequence of a feud and heated discussion about Linq being a limited technology for narrow tasks, and it's limited because it's SQL-like and is connected to enumerable. And the argument for it being universal is that on the language level, it's not the types that are implemented, it's query patterns that parse the expressions and allow us to put pretty much any code into a syntactic tree. So when we thought of creating that Linq2d to use the 2D operations on an array, we had some issues. First, how do we record operations on 2D arrays? Because usually the capabilities are quite wide, and the characteristic features of such approaches would be accessing to a number of sources, relative references, recurrent calls, and getting number of results. But you can make an abstract library, which works quite well, but the performance won't be good. So let's start with just arithmetics. Imagine we have an array of numbers, and we want to create another array that have the same numbers but plus 42. So we take two cycles, starting from 0 to 3, and calculate it. We can also declare it in a Linq style. We get rid of the cycles. We have s, which is a variable that runs through our array, and select that chooses the operator. So if it was Linq, then this code would work. But to get an array and not a linear set of elements, then we will need to use toArray. And the error from compiler we will get like this. We had a nice decision on this by John Skid to add int. We make a typization for the array, but unfortunately the array will be one-dimensional. This code is built on the trick that all the arrays in C# are just one data block, and any array is can be represented as enumerable. And this allows us to understand that as we use our enumerable, then we get a collection that has all the elements. So if we add Linq2d library, then the same code will compile into a correct result. So the same array as we got using the imperative form. So now we can calculate the elements. Not very funny. Usually, when you do the real-time stuff, you want to work with a number of elements, like with C4 filter, which is average of everything that is higher, lower, to the left and to the right in the array. Then Linq2d starts to behave differently from the traditional Linq. The variable then will not be the number, but it will be a link to the cell, to the specific cell in the array. And we can define displacements. So here is how it looks for one cell to the left, to the right, up and down, and divide by 4. And as the source is a massive of bytes, and C# cannot work with bytes, all the bytes are converted to int, so then this is a good code. If we run an imperative version, then we will get a runtime error, because we are trying to access the elements of the array outside of the current. So if we run this in Linq2d, we will also get an exception, for the same reason, obviously. We are trying to calculate the filter that is outside of the original array. And if we would use the imperative code, then we would change something in our code, maybe split it for a number of cycles, but for Linq2d you can do it like this. You can just define the reaction to the attempt to leave the boundaries of the array. You add this exception method, init value 0, and say that any attempts to access the outside of the filter need to be replaced with a 0. It's a convenient one, it doesn't add anything to average. So now we have somehow correct result. But for this filter this is not very successful, because we will get a black border, like our array being part of the bigger array filled with zeros. So our border values will be different. And this method width takes either a constant or a strategy. It's quite a complicated thing that allows to flexibly define the reaction for leaving the boundaries of the array. And we have the strategy for nearest neighbor, which carries our request to the nearest one that has the value. So those two values will be replaced by the 4. So for all 4s we get the same form, which is intuitively what is expected from any averaging filter. If we would like to work with this set of data sources, then usually it's the join operator, which is designed for heterogeneous types of data. But in our case, we just have arrays that would need to be put on top of each other, and we don't use join. Thus, in Linq2d, you just name the sources of data a number of times, and here we have L and R, and using select we can use any form like L plus R, which gives you, predictably, an array of the same size as 2 arrays with all the 5s, because the original data was prepared in this way. This is based on the implication that we have the same sizes, and Linq2d checks it. But if we try to use arrays that are incompatible in sizes, then we will get an exception. You can use the same approach to calculate a number of results in one run. You just need to return a cortege of values. Unfortunately, it's not supported by the round brackets, but you can still do it as in a manual mode. And instead of using 2array, then you now use 2arrays method, which is to highlight that you work with a number of arrays. So now you have a set of arrays, and to deconstruct, you can put them into 2 variables, both of the array type. Recurrent calculations can be a tough topic. And in Linq2d, you can, instead of showing an array, you can just use the result, and you will need to define the value that will be used when you are trying to address something outside of the array borders, and you cannot take it from anywhere else, because it's a relative call, and this also defines the type of the result. So if we send 0 there, and it means that we need an integer in return. So this select calculates the original array plus the what was on the left. So if we calculate the top left number, we sum 1 with what was outside of the array, and we put what was down there with init width. So the first line of the array will be a copy of the first line of the second array, and the other lines are a bit different. So we sum 9 with the what was previously, and in the end we get 18. Thus the array is a bi-element sum of all the elements of the array itself. So we integrate. This can all be used simultaneously. A number of inputs, number of outputs, and number of calls. So with this, we can calculate the integral of the array and the square of those also. So we enumerate the numbers. So the math is quite easy here. We add the integrals based on what was previously calculated and one current value. And why would you need it? Let's see. Let's apply Linq2d to adaptive binarization. Very well-known topic. Binarizing the text from binarizing the picture to decipher the text from the background. So if we would like this picture to be processed so that the text analysis algorithms will be able to work, the simple way would be to take gray color and to say that everything that is darker is the text and everything that is lighter is the background. Unfortunately, this doesn't work very well in real life, because in some point you can get the text color being to be brighter and in the other part of the document to be darker. So for that we need adaptive binarization and a lot of algorithms that would work with that. So you can there's different math to work with this. But a number of years ago, we've invented a way of binarization, taking a window, calculating the average brightness, and then the average variance. So after the comparison with the average brightness, we would need this will look like this. So here is how it looks in Linq2d. So it's quite big but very easy to understand. So first block is our input data. So G is the array in a grayscale, I and Q is the integrals that we've calculated a couple of slides before. Then we process the window, and the only tricky thing is processing the borders of the window, and we need to guarantee that this window will not leave the limits of our array. And this function is called integral. Everything that is to the left from our array is zeros, and everything that is to the right is replaced with the nearest neighbor that we saw in C4. And to apply this strategy, we calculate the window. So we have 4 variables for elements. Each and every one is moved with an offset, like half a window to the right. So half W is half of the window size. We choose it to be an uneven number in width and height, so that we can split it in half, so 3 by 3, for example. So one block calculates the sum of the elements, then the other squares. The good thing is that we need fixed time using just 4 calls to our predefined integrals. We can calculate the sol, and then we calculate the mean average, the variance, and in the final block we calculate the threshold height and the value by comparing it with the threshold, and putting 255 or 0 to just have 2 two colors. So here's how it looks. With 11, this is no longer very visible, but we would need the window to be even bigger, so that and here's what we see when we compare our image with the calculated threshold. And we can send it now to the language recognition software. So let's also talk about performance. You saw the functionality. Binauralization is used in pretty much everything. Let's see how much it costs. So we calculated number of filters, naive approach, something that a novice would write on C#. Someone would want who would know to how to work with arrays. Then an experienced developer would remember probably that the arrays are checked for the boundaries, and this costs a lot, and each and every call to the array would need to be checked, and we can get rid of those by going to Unsafe. So we fix the pointer and true hardcore on C++ starts there. We can also do C++ because it's more realistic. In a more realistic solution, we would probably create a library on C++ and put all the performance-sensitive code into an external implementation. We would have same naive code, but we think that the compiler for C++ would optimize it better, and it does not need to care about security and safety. So it's the same, actually, the same level of insecurity as with unsafe code, because you can make a mistake and then leave the array. So then Linq2d from SNSource and Linq2d with caching. So this definitely costs a lot, and if we run the same transformation a number of times, then you would probably wish to store it, because then Linq2d would give you a caching opportunity. So here's our binarization, 33 megapixel picture. To the left is Windows 10 on my laptop. To the right is Ubuntu, GitHub Actions. There's some lottery here, because when we run GitHub Actions, we can get pretty much any machine with different characteristics, but the relative performance is roughly the same. So naive approach on both machines would take 1,700 milliseconds. Unsafe would get us like 40%. And this explains a lot why people use Unsafe with the calculational method. And C#, C++ works even better. G++ C# doesn't work well on the current Intel processors, so C++ would give you another 25% of performance. But funny enough, cached Linq2d is roughly the same as C++ implementation. On Windows it is a bit better, on Linux it's a bit worse. It can be because of the platform, or because of the processor, with different operations being available and that cost differently, with different forecast. And Linq, non-cached Linq, would cost us a lot to convert high-level code into low-level, and it actually wastes a lot of time. So for C4, it's even better. For the same 33 megapixel picture, Linq2d wins. With Linux, it's the same as C++. C4 is quite a simple filter. It is easy to compile, and the caching does not give you a lot of results in this sense. But this is comparable with the compilers of the enterprise class. On Windows, we just compiled with C++ compiler and in Linux GCC. So how it works inside? So Linq2d takes our core filter, our filter core, a function that is consists of the elements of the array, and converts it into a function that takes the arrays of the needed types and returns a number of arrays of the needed types. First of all, Linq2d checks whether it's a managed type. Then we need to really create managed code. So we create a block expression made of the cycles, and the only improvement is because we put the filter in line in the code. So using the internal compile method, we get our candidates. But if we are lucky to have all the types in unmanaged types, the amount of unmanaged types is quite significant, then we specialize and break our cycle into the parts where we don't need to check the array borders, and we calculate we get the intermediate code for all the filters and build it up into a full method. So then we get a bytecode that is sent into JIT to be optimized for a target platform. Let's see how it looks. We need to calculate some filter that is parameterized by d, which is also an enumerator, and shows what are the coordinates where we move, and we call the transform method. This property returns to us the delegate that allows us to cache the results of the optimization and reuse it for different data. First of all, we define all the constants and all the calls that are dependent on the input data. We set the d at this point to get the highest performance, and if we had some calls, all those calls will be processed as part of the transform, and their results will be fixed. So this simplification allows us to guarantee that this one is a simplification. So multiplying something by 1 is just a constant. So instead of 2 multiplied by d, we have, you don't need to divide by 1. So this is just the sum now of 2 calls. So we can now define the size of this filter and check the size of the window. So we have width of 3 and height of 5, and this allows us to make a decision on how we divide our array to 15 parts in this case, so that we know beforehand how the core of the filter behaves. To calculate the value in each and every part of the array, we do it like this. Look, each and every parameter is checked for whether it leaves the borders of the array, and if it doesn't work, then it's replaced by 0. So if it's higher, for example, than the height of the array, we replace it with 0. And so this is how we process the variable, which allows us to optimize this. So for A, we put ing 0, and this allows us to reduce the number of branches we process. And actually the array can be of different sizes, so if it's lower than 2, or width is bigger than 1, then to avoid this branching, Linq2d, instead of calculating, it checks. It says we need the filter to be at least once to be able to be put inside the array. So that's how it looks for the A zone. That's how it looks for the B zone. It's a bit different. G is not a constant. It's actually a lot of complexity in Linq2d to define whether we will get out of the array borders or not. We try to prove that with this G we cannot exit the array, and if we fail, if there's some complex thing, and we then will have the branching inside the filter code. So this strategy works quite well. So then the C zone and other zones. An interesting thing is for the H zone, where we count on having most of the array there, because the border effects will not be too big, and most of the operations are for the parts of the array where you can actually run everything. So you have a scalar version and the vector version of the same operation. The vector version would try to find the analogs of the operations on the current processor. So for the code that I ran there, we can replace it like this, and thus run a set of elements at once. We also calculate the biggest step in this cycle. If we have special operations to optimize it and run it to maximize the amount of elements we process using this function. So if the amount of elements in H zone is not sufficient for our filter, then it's processed by scalar. Then using a method builder, we create a method that is used afterwards. Here's how the compilation looks. We have a programming language that describes the 2D operations. We would need to create some text tree of expressions, then optimize it. But if we work on a managed platform like .NET, we would need to compile it into the code and then compile it to the binary of the target platform. The benefit we have with .NET is that there is already an implemented tool that allows to do it. So moving to the abstract tree is done by the C# language, which processes the error situations, and the compilation from the intermediate code into the binary representation is done by JIT. So it does a lot of work to monitor everything. And for Linq2d, we just have the middle of the process, the transformation between the C# type. In the ideal world, the compilation would be delegated to an implemented library, but we create a lot of unsafe or unmanaged code that needs to be somehow managed. So for that, we gather that code from different parts and pieces. In part, we have also a code that is compiled in the output conveyor, but that's not too much work to do. One person with not too much background in compilers can build quite a working feature, like myself. Did we need to do it? You can turn your bread into a trolley bus, but why would we need to make C# a performance calculation language? I think that Linq2d is a proof that C# is a convenient language, and we can program our hardcore calculation tasks using C#, and it will be safe, and the program will not break. and we don't lose in the performance. The code we get is C++ on par with C++ in terms of performance. Yes, you can replace it for manual intrinsics or optimize the code for the processor, but it's much more work with much higher probability of errors. And Linq2d has an advantage. For C++, we would need a lot of different analogs of our code for different platforms so that all the customers will be able to use. Linq2d compiled for everything, and so to compile it for ARM, it would be much easier. And it's definitely more convenient than rewriting your project to a different language and platform. So I think Linq2d is a successful example. I would like it to highlight for you and inspire you into doing the same. If you have a lot of calculation heavy work, you have to compile C++ and you don't want to integrate the different languages in the project, the hope is not lost. You can use the same approaches to dynamically create highly effective code. So try Linq2d. Definitely feel free to send me an example of where you think it works well or where it doesn't work. Show me how it works on your hardware, the examples of tasks you solve with Linq2d. And if you are interested in stuff like Linq2d, then tomorrow we will have two things: David Linear on C# generator and Arjit Chinkura on 10 minutes to 3 will talk about source code and working with the source code. And also Igor Bogatov will talk about turning your code into the target platform code. Thank you, and I'm happy to answer it. Thanks, Anton. That was a great presentation, and I think someone calls us right now, maybe with some interesting question. Hello. Hi. Yeah, I hear you, okay. And we... Yeah, we're happy to listen to your question. Yeah. Hello? So the question is, Anton, thank you very much for the presentation. Did you try to implement those algorithms for the tasks on F#? No, I did not. That would be interesting, but I don't know C# to that level. The F#. We will have a presentation on F# tomorrow, and maybe, yeah, you would. It would be interesting to try whether this is doable on F#. So, yeah, the call is over. I hope we've answered the question. And we had a number of questions in the chat. They say that you can write inside of Linq and avoid using value typography. This only works if the methods that work in the query part are accepted by a delegate. If you compile the delegates, that you don't have those issues. But my first approach to Linq2d was an attempt to take delegates and put it into the cycle. So this approach was also limited in some ways, and it was not easy to develop it. So moving to the expression trees allows me to optimize it in the runtime and optimize it using arithmetics and simplification. So this is a useful part, and a lot of performance improvements is due to vectorization and getting rid out of branching. and you can implement some SIMD operations, but the conveyor speed is going down. So that is why I had to go to the expression trees, and they do give you the compilation errors. I saw that we're in the expression trees, working on expression trees in C#, and there's a lot of nice, sexy things that appear, but not everything is supported. So I'm not sure it will become mainstream. Let's hope. Yeah, let's hope that it gets there. So another question from chat: do you have examples of using Linq2d in non-classical ways, but with method chains? No, I don't have examples, but I understand we can rewrite everything for method chains. But I doubt it will be beautiful, because we move from ASTs to temporary objects and types to avoid those selects. And if we go to froms and to let, then let becomes very important. We saw how many years, how many lets we put there to avoid writing C# codes in the expression trees. We cannot put the code that calculates something or passes the data from one iteration to another there. But this is prohibited. But if you want to reuse it, then let and what is and company is much better. So it's the most beautiful as it is now, and if the filter body is simpler, then you can get the same result with a bit different syntaxes. But in Linq2d I was not doing this.